Hi, I'm Ollie. I'm an obtainium engineer and jack of all trades, and I'm here working on Electrobird. It's day 17. We were starting to work on cutting up some short interconnects last night for big fat cables inside the motor controller box. So gonna continue with that.
So I'm just marking out the motor controller FETs to go onto this heat spreader, and the heat spreader I've just pulled out of the inverter box. We can bolt that back in. I've just put a little bit of plywood in the base of the box to insulate the base of this contactor we've just put in, and we're just going to now mount the BMV shunt on the side here. We've mocked up a little bit some of the positions for the motor controller, the contactor, the BMV shunt, which is the battery monitor shunt. Yeah, we've got a pre-charge resistor down the bottom here. Oh, there's a whole bunch of things. There's a relay to drive the contactor, and yeah, we've got the DC to DC converter outside this box. We've also got the Victron Venus device, Venus GX, outside the box. It talks to the inverter and the batteries, and we've got a battery management unit up here that connects to the two batteries, that connects to this, to the Venus GX, that is. Yeah, we're starting to really make some headway on the electrical, and we'll see how we go with other things. There's still a tail shaft lying around we haven't put in. It'd be great to put that in just to wrap that up. That's not a long thing, so we might do that. And look, we will see if we've got time for other things. There's pot box to put in if we've got time, because I seem to overestimate how much we can get done consistently. Just cleaning up the points on the contactor here, which is to make and break the connection between the motor controller and the battery. Brought in new holes. These are big enough for the lugged cables to go through. Got a lot of the gear into the box now, and I'm mounting to the firewall the DC to DC converter. Now we've got the converter screwed to the firewall. We'll jump inside and pop the motor control box in. We've got the motor control box mounted inside the cab now, and we just need to figure out how the motor cables connect onto the controller. They're such fat cables, they're 50 square mil. Doesn't seem appropriate for this pathetic little controller. I'm sort of regretting a little bit this bare controller. I think I would have, next time, I'll probably take a controller that's housed with a nice robust chassis. So part of me is tempted to take little flexible leads off to some terminal posts like they would in a proper controller, so that we can put these big fat leads, bolt them on. I'm not exactly sure. I don't want to flex the board of the controller just trying to connect these huge cables. So I'm sure I'm going to regret this when the bigger controller turns up in no time at all at the post office, because it's been a lot of bloody work mounting that controller, all for a inverted commas testing. Wow, that is really bright. Good to get a bit of sun though, because batteries are a little bit low, the workshop batteries. It's day 20. Time's charging on. We've still got that tail shaft to put in. Still haven't put that in, so I'd really like to get that in this morning. Probably first thing we'll put that in. It's all done and we'll be quick. So yeah, let's get started. Let's get that tail shaft in.
Okay, I've got some bad news. This is the Tailshaft rear universal joint, and it doesn't match up with the diff now, because in an earlier episode we changed the diff. Different bolt size and slightly different bolt separation on the flange. Oh, this is a pain in the ass. This is the tailshaft flange of one that will fit it, but it's a different tailshaft flange on the gearbox. So I reckon we're going to jump into giving these a quick brush up, clean some of the rust off the mating surfaces. Rightio, we're going to try and get this brake drum in. Got to pull the other one off, and I bloody hope it's the same. But knowing the experience so far, it probably won't be. So here we've got back on the bench after putting this drum in the vehicle and taking that one out. We've now realised that the tail shaft that goes with this one is incompatible with the tail shaft that goes with this one, which is also incompatible with this tail shaft. Yay, Toyota! Changing things all the time. Righto, let's go get that other handbrake drum housing off the other gearbox. Somewhere down the back here we've got a gearbox that hopefully, there it is, hopefully that's the right, looks like the right size, but we'll line our other one up and see. That's the bigger one. It's also got different thread, looks like it's got a fine thread. It's going to be interesting finding all the nuts. Let's do it. Now we need those tail shaft bolts. Damn, not here. I'm walking back over to the to some of the other Stouts over there because I can't find the correct threads for the studs on the this new drum that we've got that's got the right bolt pattern for the tail shaft that we need to go onto the tail shaft flange on the diff, because the diff is different to the one that was in there. Yeah, a bit ridiculous, but anyway, that's the whole thing. We'll go over and get it. Poor old Juliet, the 76 Stouts, dilapidated. It was another parts vehicle. I did drive it out of where I got it from. Thanks, Ollie. And I'm going to pull the tail shaft off that and we're going to grab the bolts. Thanks for the parts, Juliet. 1976 Toyota Stout. I did drive her here. I think we got what we need. Finally got a tail shaft in the vehicle. It only took most of the day with those few cascading consequences of changing the diff. We did have to put a different tail shaft in it, so the one we reconditioned is going to have to be for something else. We've got it in the vehicle, so let's move on from that. Got a little bit of time left today and wanting to get some of the holes drilled in the cab of the 68 Toyota Stout to allow the motor cables to go back to the back of the ute where the slip-on goes on, which is where the batteries are going to be housed. Down on the floor here on the left are the cables going to the battery coming out of the motor control box. So I'm going to run them along inside the cab and go under the seat. Well, it's day 21. We had a big distraction yesterday on the tail shaft, and we had to pull the tail shaft out and get different flanges on the gearbox to match the different diff we'd put in. But with that behind us, that took most of yesterday. But with that behind us, tail shaft's in, all the driveline's good, all the brakes are good. Brakes are bled. Tess helped me do that one evening there. I didn't include the bleeding of the brakes because it's a lot of me opening and closing the bleed nipples and her pressing the brake pedal again and again and me going round and round. There's plenty of videos on the net about how to bleed brakes. The procedure in the Toyota manual basically says start at the wheel furthest from the brake cylinder and work your way back. That's a whole other thing. But anyway, Blakes are bred. We've got breeding Blakes now. Anyway, so mechanical side's good, I think. And yesterday evening we started doing the cable runs, which you saw, drilling holes in the cab. So we've got some cable runs going to the back of the ute now, and we can't exactly get the layout right until the slip-on's on the ute, but we're gonna get it set up temporarily so we can drive it to test it. We've still got the accelerator pedal to put in. We've got a few things to do, so really keen to get into it. Let's get started. Last night we were drilling the holes and this flexible conduit, and we've just got that coming out now. So we're going to feed them up onto the back of the ute to see whether we can get the batteries into a temporary position. I'm here in the cab. Okay, just having a look at this accelerator pedal here. Looks like we've got brown and black wires there coming down to the potentiometer, which is the main thing that's going to give us our variable signal. Blue and yellow green are going to be a switch that we can use however we want. So very, very simple. Let's go ahead and mount that. Just cutting a little shim to go under the accelerator pedal.
Cut our little shim.
Okay, we're just looking inside the motor control box, and that little green terminal block there to the left of the red dip switches are the 4 inputs we have on this particular motor controller.
So we've just wired up the control signal through to the motor controller, and now we're going to need a little bit of power from the 12 volt DC to DC converter that's mounted to the firewall here. Cool, let's get this 12 volt hooked up. I've just been working on the wiring loom of the vehicle, changing over the power input to the wiring loom of the vehicle to come from this 48 volt to 12 volt power supply. So that's the red cable coming out there, and it's heading over to the little fuse block down in here. And now it's time to get this connected to the key, because that's our enable line for the 12 volt, which is going to turn everything on. So I've just come around inside the cab. Pretty simple. It's just going to be 2 wires. It's either on or off. So the key's got a simple job. Very easy to diagnose if there's an issue. And I've just connected all the wires that the key would have connected are connected. So that means whenever there's power, whenever this turns on, which turns on the 12 volt DC to DC converter, then all of the things that the key would have turned on are on. So these are the batteries. They're like 47 kilos. These will be shipping with a limited state of charge, because that's part of the requirement for shipping lithium batteries, regardless of their chemistry. So a manual, quick start manual, material safety data sheet, comms cable, some little feet, screw hardware. So these
these are pretty economic per kilowatt hour. Under $750 a kilowatt hour. Look at that. Beautiful. I reckon we're gonna get this up on the back of the ute. Yep. That's heavy enough. I wouldn't want to be moving too many of them around. Awesome. BYD haven't changed the terminal bolt size. It's still 6mm. Even though they're double the capacity of the earlier ones that I've got in the building here. Gonna make some custom lugs that I have a 6mm hole, fit in here, and take 35mm cable because I think that's what I want between them. I got some copper pipe here, but it's secondhand, it's old, so we're gonna scrub it up to make sure it's got all fresh copper on the outside and on the inside, and then we're gonna crimp it on to the end of our 35 square mil cable with a flattening on the end and drill a hole, and we're going to solder it on so that no verdigris and crap can get between the two. Let's make some lugs. Righto, so we've made up the short link cables. We just need to put some heat shrink on them now to cover them up a little bit and identify them. But yeah, they're narrower, so they'll fit in the tabs, and they're soldered on and crimped, and they're 35 square mil between the batteries and 50 square mil coming off either side of the two parallel batteries. I'll drill them now, and then we'll heat shrink them and put them in. You finished getting the rats in there? Here you go, mate.
There we go, we've got the 4 link cables finished up, so we'll whack them on the batteries. Here we are inside the BYD Flex 5 kilowatt hour unit. Looks like on the top here we've got a cell monitor of some type with all the cables coming out going to the cells and power coming to it. There's probably some comms, I'm not exactly sure where, but underneath it here there are a few other boards. This is a contactor down here, and over here we've got our shunt, which looks like it's 150 amp. I can't really tell what's going on this side. I'll try and give you a bit of a look at it. Those of you electrical engineers might be able to give a bit more insight. I would say they're the FETs to turn the pack on and off. People more knowledgeable than me are welcome to pipe up. I will take some photographs for you. Anyway, here's the actual cells. You'll be interested to see, it looks like they're welded. The tops of the bars look like they're welded. And it's very dense. Like, when you have a look overall, there's no room spare as far as I can see. Very well packed. But there is a lot of room up front here, so I guess volumetrically they could fill that out a bit more, but pretty good. Anyway, I'm going to button this back up. We're going to continue with the commissioning process, connecting it to the Victron Venus GX. Righto, we've got the battery cables hooked up. This is the low voltage battery management unit. So where it says inverter, we've got to hook that up to the Venus. Ethernet is for internet, so it can update itself. And the BMS goes to these modules. So we need a standard Ethernet cable for the BMS cable, and the inverter cable needs to be custom. We have to run an Ethernet run from the battery box to the BMU, because we're going to mount the BMU in the cab. I want to do that out of good quality Ethernet to keep it shielded. So this is a shielded Cat 6. Oh, well, why don't we wrap it up there for the night? Yeah, I'll see you in the next episode.